like I said, more of the same thing. We're going to keep talking about functions and kind of what makes them special and how to use them. And then for this afternoon session, we talk about returning functions from functions. So this morning was about using functions that were passed into functions, and now we'll talk about returning functions from functions. And then also closure, which would explain why we want to do or why we want to return functions from other functions. So the theme of this morning was, hey, functions are just like everything else, right? Very standard. You can use them, you can pass them in, you can do whatever you want to them. And that theme is going to continue here, right? In this function return a string, we return a string, or return a number, or return a boolean. Everything's good. So therefore, if functions are just like everything else, then guess what? We can also return functions. And here's, once again, right, I just want to really quickly call out this skill. On lines 1 through 3, we create a function called greetMe. On lines 5 through 7, we return greetMe. But notice how when we return greetMe, we're returning the variable. We're returning the function, right? Nowhere on this page do we ever invoke greetMe, because I never see greetMe with an open and closed parentheses after it, except obviously for when I define the function in the first place, right? So on line 6, when I say return greetMe, I'm going to look for the variable called greetMe, and I'm going to point to whatever the variable is pointing to. In this case, this function. So just to kind of really reinforce this notion, here we're returning the function itself. We're not ever running that function. In fact, just from looking at it, like if lines 1 through 3 didn't exist, but I knew there was a greetMe, I actually can't even tell you if greetMe is going to be a number, a string, a variable, whatever, right? It could be anything. So once again, we're returning a function, but we're not calling it. We're not invoking it. Therefore, when I try to console log out these three different things, right? When I console log out what greeter is, well, greeter is equal to whatever we get when we invoke getGreeter. And getGreeter, once again, just returns greetMe. So this means greeter is equal to whatever this returns. So greeter is now pointing to the same function as greetMe. And in fact, if we do a console log, we'll see the type of greeter is a function. And if we actually try to print out what greeter is, we kind of get this array syntax again, except this is not really an array. This is just how functions get printed out. And whereas before when we had an anonymous function, we could say this is a function, and now this tells you, hey, it's a function, and the name of the function is called greetMe, right? Which we just found on line 1 there. So this is just telling you what the type is. This is what a function looks like when it's being printed out. And then lastly, on line 13 here, this is the first time we actually invoke greeter. Well, if greeter is equal to greetMe, and greetMe is equal to this function here, line 13 is the first and only time on this page where we actually invoke the greetMe function. And so that is why hi from line 2 gets printed out here, right? Up until line 13, greeter is never invoked, or rather, greetMe is never invoked, and greeter is never invoked, so this function never runs. But once we actually invoke it on line 13, that's when this console log actually shows up. So once again, just kind of really just to reemphasize that here we're returning a function without invoking it. But we always have the option of invoking it later if we want to. Okay? Good? Make sense? All right. Okay. So then, if I look at this function again, or rather, if I try to look at this function again, notice how now the difference is, hey, we now are putting an open and closed parentheses after the greetMe, right? So now we're no longer returning greetMe. What are we returning?
Hi.
No.
Return value of greetMe.
Once again, right? This becomes now what? Yeah, exactly. The return value of greetMe, right? Because now we're invoking the function. This is now no longer a function. This is whatever the return value of the function was, right? We run this, and so when I run greetMe, what gets returned? Well, there's no return statement in this function. So by default, it means this function is going to return undefined. And because it returns undefined, the console logs don't really matter, right? They're just things for us to print out, for us to see as humans. But really, this function is going to return undefined. So this whole thing becomes undefined, right? And then we're going to return undefined to here. So this thing now becomes undefined. And finally, that means greeter is equal to undefined. So therefore, when we console log out type of greeter, we get undefined. Well, actually, backtrack again. This high, where does this high come from? I'm sorry, Sarah?
Is it from the first one, the console log?
Right, but where do we run it? Or where is this actually being run? Not line 9. Or, yeah, I see what you're saying. Yeah, so line 9 calls get greeter. Get greeter calls greet me, right? But here on line 6, we actually invoke greet me, right? And so this greet me here is what's console logging out high. So you're right, Andre. On line 9, this does eventually trace up to so that we run the high first. It becomes a console log high, right? And then on line 11, we're saying console log what greeter, what the type of greeter is, and we get back undefined, right? Because once again, this is returning undefined, and type of undefined is undefined. In fact, if we look at what greeter is, it is undefined. And then lastly, here on line 13, when we actually try to invoke greeter, because maybe we were dumb, maybe we made a mistake, and we thought this was still a function, we try to invoke undefined, and now we get an error. If you can't see it clearly, the error says type error. Greeter is not a function. Or rather, JavaScript is trying to invoke this function, and it's realizing, hey, this is actually not a function. I can't invoke it. So once again, right, at every single juncture, be very clear about what it is that you're looking at. Are you looking at the function, or are you looking at whatever the function is returning? If the function is being invoked, then the function matters. The function doesn't really matter anymore. What matters now is what it returns, right? If you're not invoking the function, then you can treat it like you would like a normal function. So that's just a distinction that you always want to be very careful about. Okay, so here we're actually seeing something that's it's probably new, but it's also not that different. In that we used to always define functions at the top of the page, but now within the scope of a function, we can really easily create another function and just return it right away, right? Hopefully this is something that that even though we haven't seen before, it's not something really hard for us to imagine. And so now when we talk about let greeter equals get greeter here, we invoke get greeter. Get greeter is going to say, okay, I'll skip line 3 through 5 for now because I just need to know that this variable exists. We get to line 7, it says return greet me. Oh, what's greet me? Greet me is just a function. Are we invoking greet me here? We're not invoking greet me, right? So I'm just going to return this function. And so this becomes the function, greet me. So greeter becomes greet me. And if I if I invoke greeter, it becomes equivalent to us invoking greet me on line 3, and that's where we get the console log out high from. Right? So this is just idea of like we're playing around with scope now, and in this function we create another function that we return. Cool? Okay. And then this is almost identical to the previous example, except what's different this time? Matt, what's different this time? Well, we invoked it online last time too. Anyone? Yeah. Well, we were returning a function last time too, weren't we?
It doesn't have a name though.
Exactly. Last time we created a function, we gave it a variable name, and we returned the variable. This time, so this is the last example, right? We created greet me on lines 3 through 5, then we returned greet me. Here, we basically just said, hey, let's get the same thing accomplished, except we won't ever have this intermediary variable called greet me, right? We'll just create a function and return it right away in the same line there on line 3. So now we're basically returning an anonymous function. We're doing the same thing, right? Before we just the equivalent if we didn't use functions, if we use numbers, right? Before it was like let x equal 6, return x. Here we're just saying return 6, right? We just kind of bypass all the variable creatures and just return the function directly. Everything else on this page is identical to the last example. Really, the only difference is now we're just creating and returning an anonymous function in the same step. Okay. So let's keep going here. Once again, we have our return. We have our anonymous function that we're returning, except now the function takes in an argument. Therefore, when we invoke this getGreeter, we are invoking getGreeter because I see the open and close parentheses after it. We're invoking getGreeter, and so this is going to return what? What does this become? Everything on the right hand side of this equal sign. What does it become? I'm sorry? Yeah, it just becomes a function, right? Whether or not it's an anonymous no longer matters at this point, right? Like, because this is just going to give you back a function. If it's named, it's still a function. If it's not named, it's still a function, right? So, in fact, this is going to give you back a function that we then assign to this variable. So you can almost think of it as, oh, this variable now has a name, right? This is greeter now points to a function. Cool. So if greeter is becoming this function, this is just showing that, hey, we can invoke this function like we do any other functions, which means we can pass in arguments that this function is trained to take, right? So this function is trained to take in a name argument, and it console logs out hi name. Well, if we invoke that now with Marie, then we get hi Marie. So nothing too complicated, just this idea that like, this is like greeter is now basically that function, right? So we invoke it, like we can pass it in things, we can do whatever we want with it, like we would any normal function. And if we keep kind of going down this line here, one of the things that we're going to talk about is, okay, so why would I ever want to actually do this, right? Like, what's the point of returning a function within another function? And that hits upon something that called closure. So before we talk about closure, let's talk about scope again. We reviewed scope, we talked about scope earlier this week, but who remembers what defines a scope?
The brackets.
Curly braces, yeah.
Sorry, yeah, the brackets.
Everything's a bracket.
Yeah, sorry.
So curly braces, right? So curly braces, there's two sets, if you will, in JavaScript. There's what we call block scope, which are things that come with like smaller scopes, if you think of like if loops, while loops, for loops, etc. And then you have the function scopes, right? And those are designated by the curly braces that are used to define a function. Okay. If we look at this greeter function here, we have a name variable, we have a function called saysHi, and when we invoke saysHi, it console logs out hi space name. And in fact, if we do run greeter is going to run line 14, is going to take us to line 6, 7, 8, it's going to execute line 11, line 11 is going to lead us back to line 8, 9, 9 is going to look for name, it's going to find Marie, and it's going to run it, so we get back hi Marie. Right? This is kind of how we expect JavaScript to work. This is how we expect scope to work, right? When we invoke greeter, everything kind of happens very nicely within this function scope for greeter. Now, or rather, sorry, let me just clarify. Here, when it says hi is trying to look for a name, it says, does it exist in my personal function scope? And the answer is no. Okay, does it exist in my parent scope? Oh yeah, it does, right here, name equals Marie. Great, use that. So that's kind of like that's kind of how we're looking for the variable there. Now, the reason why closure is really okay. The reason why this is important is because we're going to see how, so far what we said is, hey, if you're outside of a function scope, you can't have access to what's inside that function, right? Like you can look outwards, yes, but you can't look into a sibling scope or into your children's scope. Well, closure actually gives us a way, not necessarily to look into the scope, but it will give us a way to access variables within that scope in a fairly controlled setting. So if I have this function called getGreeter, it console logs out getGreeter is running. I create a variable called name, and I assign the value of Marie, and then I say, hey, this greeter function is finished running, and I console log out hi Marie. Okay. When I run this page of code, right, line 13 is going to execute getGreeter. So this is going to run. So that's why we console log out getGreeter is running. Name equals Marie. getGreeter is finished right here. And then we return this function, right? So greeter is now equal to this function. And once again, when we invoke greeter again, we're going to get back hi, comma name. name doesn't exist within the scope of this anonymous function, but it does exist within its parent, Marie. So we get back hi Marie. Or rather, we get back hi Marie. This looks like what we had before, except the only kind of, or rather, this is what we had before, except the one thing here that we might have taken for granted when we looked at this on the previous slide was, guess what? Now I can invoke reader, and it can actually give us, it can kind of pseudo give us access to Marie. So if we extend this concept out a little further, okay, here, this one is even more clear cut, right? It just takes in a parameter called name, and it returns a function that says console log out hi comma name. So here, when we invoke get reader here on line 8, it takes us to line 2, and then on line 3, it returns this function. Notice how up until this point, we haven't run this function yet, right? I've only passed this value back and forth, and it could be anything. It could be a number, a string, whatever it is. Nothing so far has indicated that I'm actually going to run this anonymous function. Greeter becomes that anonymous function. However, now if I invoke greeter, I get hi Rosalind. Is it far? Sorry, I'm kind of building up to how do we actually get access to that variable later on, but just taking it step by step, does each of these examples kind of make sense in terms of how they're working? Okay. Yeah.
Could you just do the previous slide again?
Sure.
Just go to the previous slide.
This one?
Yeah.
Yep, sure. So lines 1 through 11 are defining a function, right? And we'll skip it for now because line 13 is kind of where the first, I guess we'll call it the first kind of action is happening, right? We've created a variable called greeter, and we're setting it equal to whatever get greeter is when we invoke a greeter, right? This is not get greeter. This is a return value of get greeter, right? Because we're invoking it here. So when we invoke get greeter, what does it return? Well, when we invoke get greeter, the first thing it's going to do is console log out this message. So that's what we see here. Then it's going to create a variable, whatever. Then on line 6, we're going to console log out this other message, which is what we see here. And then finally, it's going to return this function. Notice how it's returning a function. It's not invoking the function. It's really just saying, here's a function. Take it. So this now becomes whatever getGreeter returns, and getGreeter returns a function. So now greeter is equal to a function. And then lastly, when we actually invoke greeter, that means we're invoking this function. When we invoke this function, what happens is this will console log out hi comma name, right? Hi Marie. And the question, and I guess the whatever, however you want to call it, but like the interesting thing here is when we invoke greeter outside of this getGreeter method, we still have access, or we're still able to use this name equals Marie variable that we created, right?
So if we didn't have line 14,
Yep.
it would have just printed out getGreeters running, getGreeters finish.
Yep.
That's it.
Yeah.
Okay. So it's by invoking the function that you get the return function. Like you get hi Marie. It's by invoking getGreeter.
By invoking getGreeter, we have access to this anonymous function. By invoking this anonymous function, we have access to hi Marie. Yeah. Okay. Okay. And then this is kind of another just really quick to show you just kind of, like, I mean, this really should be a refresher on scope more than anything else, right? Just like before, we have getGreeter Marie, except now Marie is now what? Name 1. And then we still return an anonymous function, right? And when we invoke that anonymous function with Rosalind, which is called name 2, we actually console log out hi Marie meet Rosalind, right? Same concept as before, except now we now have variables that exist within this anonymous function, name 2, and once again, it still has access to its parent variables, name 1. Okay. So kind of like embedded within all of this, or rather we talk about closure, why this is super important is because, I've created a function and I was able to create variables inside this function, but I'm able to use those variables outside of that function, right? If I go back to the previous example here, when I invoke greeter, I have access to Marie. Even though if I look at just line 9, I actually don't know like where Marie was created, right? It could have been passed in, it could have been something that the function itself organically created. But the point is, I have a function that is able to access other variables inside getGreeter, right? Without this function, I can't access those variables, right? There's nothing that allows me to go and look inside the getGreeter scope and say, okay, great, what variables do you have? Can I use them, right? The function becomes the only way through which we can access the variables inside getGreeter. So, seeing some confused looks. So, okay. So if I have a function out here, and what I'm trying to do is I'll call it David again, right? And I'm saying, like let number equal 5, right? If I leave that function, there is no way for me to ever figure out, 1, to know that the variable number exists, and then 2, to know what the value of that variable is, right? Like there's nothing I can do here that could ever help me get access to that number variable, right? Because once again, I'm outside of this function scope. I can't look inside of it, right? But what we've done now is we've said, hey, if I return a function that console logs out number, and I say let x equal David, when I invoke x, I now have access to this variable, right? Like, so when we talk about closure, is this idea that you're actually able to kind of enclose over the variables that you have. And so when this function is created, the scope of this function the scope of the function is based on where it was created, not where it is used. Yeah. Right? So here the scope of this function is going to be my function and my parent's function. Right? So when even though I am using this function outside here, like outside of this David function scope, I still have access to the things that are inside of David. Right? So when we create this function, it encloses upon in its scope everything that its parent functions had access to. So this basically gives us a way to access variables that we couldn't access otherwise. And so when we talk about in today's problems, or in today's workshop problems, you're going to start seeing examples in which, hey, that's actually super helpful, right? Because right now, so far, what we've done is we're saying, hey, I'm going to create a bunch of functions with these variables, right? And I either have to use them inside this function, or I have to create a brand new function that maybe copies everything else and then changes 1 or 2 things. Now what we're able to do is kind of take what we need and add in other things kind of on the fly. So if I go back to this slide here, right? On line 7, or between line 7 and 8, I create 2 variables. One's called introduce Marie to, and one's called introduce Rosalind to. In both cases, I'm invoking the getGreeter function, right? And passing in a name, which becomes name 1. In each case, I'm getting an anonymous function back. But these are different. Like, these anonymous functions do the same thing, but they're different. They have no relationship to one another, right? Because remember how I said a function's scope is determined based on when the function was created? When this function on line 7 was created, name 1 was Marie, right? On line 8, when this function was created, name 1 is Rosalind, right? And so now I have a function that permanently remembers what name 1 was when this function was created. And I have another function that permanently remembers what name 1 was when this function was created. So that's why on line 10, when I say introduce Marie to Dorothy, I get hi Marie, meet Dorothy, right? Because this anonymous function that was returned that became introduced Marie to, this remembers that, hey, name 1 is Marie. Similarly, when I say Albert, it remembers that, hey, name 1 is still Marie. So hi Marie, meet Dorothy. On the other hand, when I look at what introduced Rosalind to refers to is when introduced Rosalind to was created, I ran getGreeter again from scratch, and I returned a brand new anonymous function. But within the scope of this anonymous function, name 1 is going to be Rosalind. So when I say introduce Rosalind to, and I say Barbara and Isaac, it remembers that, hey, I'm looking for name 1, and in my scope, in my worldview, name 1 is Rosalind. That's why it remembers to say, hi Rosalind, meet Barbara, and then hi Rosalind, meet Isaac, right? So here, what we're able to do is we're actually able to leverage one function, and we're able to create two, or rather, we get back 2 distinct functions that are basically the same, except the only thing that's different is they have a different, in their worldview, they have a different memory of what name 1 is. Right? So we use the same function to multiple times, except each time there's a slight difference based on what we fed into it when it was being created. Right? Without this context, if I wanted to create an introduce Marie to or introduce Rosalind to function, I really couldn't unless I literally copy and pasted 2 functions that are exact same, except in one I have let name equals Marie, and the other one I have let name equals Rosalind. Right? Now I'm able to have one function, and I can pass in whatever name I want, and the anonymous function that I get back from that will permanently remember that name 1 value. So it's a little bit of like right now I'm talking to you about it, like it may seem kind of trivial, right? It may seem like, oh, like okay, but like so what, right? Like what's the importance of this? But one of the biggest things in programming is to make our code as reusable as possible, right? You don't ever want to be writing the same things over and over and over again. And now what you're able to do is you're actually able to create multiple little worlds, almost like multiple scopes, but multiple little worlds of like, hey, for you the world is in this state, for you the world is in this state, and for you the world is in this state, right? And now from that same function, you're able to create kind of multiple instances or multiple worlds that you can use at any given time, and that world is being maintained, right? So when I say create, introduce someone to function, I can give you a name, and when I get back a function, that function will remember that name forever. So let's take a look at one of the workshop problems here. Or actually, before I do, are there any questions about that last slide there before I move on to the workshop questions?
Well, the second to last slide I had a question on. So, for instance, the introduce Marie to get rid of Marie. So what happens there because there's no name to? So what actually happens there?
Sorry, which line is it?
I guess I'm just trying to see how things go in order. So I get 10 down because obviously there are 2 names.
Yep.
So what happens on 7 and 8?
Yeah, on line 7 we run getGreeter function, right? And we say let name 1 equals Marie essentially.
Right.
Right. On line 8 we're running a brand new instance of getGreeter. It has no connection to the other instance. But instead, what we say is we say, hey, guess what? Let's run getGreeter, and name 1 is equal to Rosalind.
No, so I get that. So I guess the part that I'm missing is why aren't we going to, so like for line 7 and 8, how come we're not getting to line 2 and 3?
We are. Or rather, we're getting here in that we're returning this anonymous function. We're just not running it.
And so we're not running it, why?
Well, do you see a open and close parentheses after we define the function?
As far as return function name 2?
Yeah.
So aren't those the open and close parentheses?
Well, so remember, like here we're defining the function, right?
Right.
So remember how so let's just get rid of all this.
Okay, so let's say return 5, right? So remember how we talked about how in this case David is different than David
Right.
invoked, right? Well, here we still have this David open close parentheses, right? But I'm not invoking it there, right?
No.
That's just the definition.
Gotcha.
That's just saying this is what a function is, right? Same idea here, right? This open and close parentheses here, that's just part of the function.
Right.
If I want to rewrite it, I can write let x equals function that and then return x.
Gotcha.
But in both cases, this is part of the definition. This is not part of the invocation, right? The invocation, we return this anonymous function, and up until line 8, this anonymous is never invoked.
Okay.
But when introduce Marie to introduce Rosen to becomes an anonymous function, then we invoke it down here.
Gotcha. Okay.
Yeah. Any other questions? Okay, so let's take a look at the first workshop problem together. Okay, so let me just figure this out. No. Okay, so let's take a look at Bill's builder, or Biller builder. Whoops. Okay, so the premise of this problem is I want to be able to create something that is able to I think calculate tax bills. Right. So I want to build a function, Biller builder, that takes in the name of a U.S. state as a parameter. Okay, Biller builder will then give me a function that will allow me to calculate how much something costs based on the price of an item and that state's tax rate. Okay, so let me just copy and paste this here. Okay. Okay, so let me copy and paste this problem. So let me define this now into steps. Okay, so step 1, create a function that takes in state. 2, return a function that takes in price. Or rather, create a function to take the price. 2, based on state, set tax rate. And then 4, returned function should multiply tax and price. Okay, so these are my 4 steps here that I want to kind of execute on. Now, let's say the idea of closure didn't exist. How would I do this? Well, if I have a function and I call it, for example, cost calculator, right? I could have it so that it could do something like this. It takes in price, rather it takes in state, comma, price. Trying to think of a way to show this. Okay, right. Okay. Okay, I see it. Okay, gotcha. So something called, let's say, New York calculator, right? This could return something like 1 plus 0. So for New York, we charge 3% for shipping and 4% for tax rate. So we'll just say 7%. And then for New Jersey, it's 5% plus 6.6%. So we'll just say it's 11.625%. Okay, makes it a little bit easier. We can make a function called New York calculator, and when we do, it could take in price is equal to 1 plus 0.07 multiplied by price, right? And this would give us like a good calculation, right? It would say, great, for the New York calculator, if I give you a price, I just multiply that price by 1.07, and I get back how much that item will cost in New York, right? But if I wanted to do this for in New Jersey, what I need to do is I need to actually copy that same function and say, okay, let's rename it to New Jersey calculator, and now this becomes 0.11625. Right? Similarly, if I had a if I want to do this in California, then I would need a California calculator, and I would need to add in another number here. So do you see how much code I'm repeating each time? When in actuality, the only thing I'm really changing here is I'm just changing one number, right? I'm just changing what this number is. Yeah, Sophie?
But we could have also done it through the switch statement.
We could do it through a switch statement, and in fact, the answer kind of somewhat resembles a switch statement too. But the goal here is to show you how we could do this with like a flat function, but even in the cases of a switch statement,
More cost.
yeah. So like here, I'm gonna do it like kind of like with scope, and then we'll talk about kind of why it's a little bit better from like a user standpoint, and then we'll talk about why switch could also work. Okay, so there is a way to do this without scope, but if I wanted to do this in the way that the problem is asking me, it wants me to build and they call it a biller builder. So I'm called a biller builder, and it takes in what? A state. Okay, and that's my step one, right? That's pretty much it. The next one is based on state. We're able to set the tax rate, and so here actually we actually could use a tax rate as well. But let's just say, let tax rate. Okay, and then say if state is equals to NY, tax rate is equal to 0.07. And then I'll copy this and say else if state is equals to NJ, tax rate is 0.11625. Good? All right, so that's my step 2. Step 3 is I'm returning a function that takes in price. And then step 4 says my return function should multiply the tax and the price. So here I return, yeah, okay. So here I'm returning tax rate plus 1, or rather I should say 1 plus tax rate multiplied by price. Okay. Now, if did I forget something somewhere? Oh, else if. Okay. So let me share this code too. Now, what kind of happens is if I look at the way that the code is running, what we actually want is now if I wanted, for example, if I wanted to get like a New York tax calculator, I could just say let NY calculator equal to biller builder multiplied by NY. Similarly, if I wanted a New Jersey calculator, I could just say let NJ calculator equals biller builder by NJ. And the reason why, so we could have earlier, to Sophie's point, we could have used a switch statement that had every single state's calculator and just based on the state gave you back a function based on which one it is. But here we still have kind of a very similar logic, and in fact this could very well be a switch statement. But the pros of this is, one, we're able to use biller builder multiple times, right? At every single instance, all we need to do now is tell it the state. Secondly, and this is a bit more about security and a bit more applicable to code bases in a larger environment, NY calculator now only knows what the New York tax rate is, right? This function doesn't need to know what every other state's tax rate is. Do you see that? Like, if 50 states all had their own tax rate, it only needs to know what its own state is, right? So let's take something even more kind of maybe more personal, right? Let's talk about phone numbers, right? You don't want to have a massive function that has everyone's phone numbers listed, and based on what you give it, it just looks up. It says, "Oh, right, this is Alex's name," or "Oh, this is Jose's name. Here's the phone number," right? You want to have a function that only knows Jose's phone number, or only knows Alex's phone number, or only knows an individual phone number. And so by doing this, we're able to do is we're actually able to set the tax rate for just that state, right? Or in some cases, get the phone number for just that state or for that person. And then we return a function that has access to the price, which we're passing in, so that's cool. But it has a reference to only one tax rate, and that is the tax rate for that individual state, right? If we put in the context of phone numbers, this will have access to just the phone number for that one individual person. And this function here, it is not able to go through and look at other people's phone numbers, look at other people's at other states' tax rates. So it's incredibly compartmentalized. When we first started this class, I did mention with functions in programming, especially, you want the function to know almost as little as possible to get the job done, right? You don't want to say, here's everything you need to know, now do it. It says, hey, you want to do this one thing. What do you need to know how to do it? You need A and B. Well, here's A and B, right? If you imagine this in context of let's say you're on Facebook, right? And you want to ask Facebook, say, hey, can I access this photo, right? You don't want everything on the page to know your password. You only want the things that need your password to know your password when it makes that request, right? And so this is also another way for us to, using a function, is to give back multiple functions, and each one of those resulting functions only knows what it needs to know, right? And so this is, in some ways, a much more preferable pattern when you program than to say, well, hey, let's just create one single function that has all the information in one place, and then we'll just use that over and over and over again, right? This is just a lot more safer, a lot more secure, and it's a lot more reusable. There's a lot more examples of why it's more reusable, but for now, it's gonna take my word that it is. But are there any questions about kind of conceptually what this function is doing, or kind of why we choose to do it this way?
So just a question, if you wanted to return the price, basically, so you do New York calculator, then you invoke that.
Yep, exactly. So if we do this right now, nothing happens, right? We created two more, we got back two more functions, and then that's great. But if I actually wanted to calculate it, then I would do New York calculator, and I'll do 100. I should get back 107. And in fact, let me just copy and paste this code into Repo to make sure that I did meet all the requirements. Uh-oh, 2 failed. 267 point. Did I miss input the tax rate? Well, I added a one lump sum, didn't I not? Oh, wow. I'm sorry. Okay, so if you look at the problem, I think I did this wrong. You multiply by shipping first, and then you multiply that total by sales tax. Okay, cool. So let's change this problem on the fly then, right? Let's have two variables. One's called ship rate, and then one's called tax rate. So here, all I would do is ship rate is equal to 0.03, and then this is 0.04, and then for New Jersey, it would be 1.05, and then this is 0.6625. And so now my final math is going to be 1 plus Yeah, so 1 plus ship rate multiplied by, I should just copy that, multiplied by 1 plus tax rate multiplied by price. Probably a better way to write this mathematically, but let's run it. Okay, great. Now I'm good. So let me copy and paste this back into the function. So this doesn't change the approach to our problem at all. It's just I did the math a little bit out of order relative to how they wanted me to do it.
And in order to reuse this, the second function, the one that returns,
Yep.
needs to be anonymous, right? If I give it a name, for example.
No, not necessarily. So let's say I say, let's say let Sophie equal this function, and I just return Sophie. This will still work. Oh, yeah, ignore the math part. But yeah, that will still work, right? So usually people use anonymous function is because conceptually it's like, why would I create a variable for something that I'm going to return right away anyway? There's no point, right? It's like, I mean, I can only think of like incorrect analogies right now, but it's like, like if I'm going to serve you a bowl of cereal, right? Like there's no point in packaging up if you're just going to open it up again. It's like, oh, like I'm going to return this. I'm going to create this just to return it. Well, just here you go, right? Like there's no point in packaging it up. Usually you use variables when you want to reuse it somewhere else on the page, and it's not easy to reference. So this will also correctly work, right? Because once again, the scope of our function is based on where the function was created. So in this case, the Sophie function was created here. So this is the Sophie scope. It has access to the scope within itself. It has access to the scope within Builder, and then it has access to that parent scope too. Yep. Yeah. So just to prove that out, if I replace the code with this, everything should still pass. Yeah, it pass. Okay. Any other questions? Alrighty then.